Good day, viewers all over the world. You are welcome to Troiden online class. Today we want to look at the second method that we can use to find a particular solution. That is when you have linear non-homogeneous differential equations. There are two solutions when we have linear non-homogeneous differential equations. We have complementary solutions and particular solutions. So in our past videos, we have talked about the first method of undetermined coefficient. So we said we can use two methods to find a particular solution. Either we use the first method of undetermined coefficient, or this second method, variation of parameters. That is, this another method of finding a particular solution of an nth order linear differential equations. Nth order simply means it can be order 2, order 3, order 4, and what have you. So let's look at this equation 1. This is a linear non-homogeneous differential equation. But once the associated homogeneous equation, that is, when we equate the right hand side to be equal to 0, we are going to have homogeneous. And once we have homogeneous differential equations, we only have one solution, which is the complementary solution. When this is equal to this, is known. That is, once we have gotten the value of y of c, this general solution to this is y is equal to yc plus yp. This is the complementary solution, and this is the particular solution. So once we have discovered, we know the value of this yc, the complementary solution, then we will be left with the particular solutions. So once we know, when we equate L of y to be equal to 0, we'll be able to get the complementary solution. So once we know the complementary solution, and we are required to find a particular solution, there are two methods that we can use. We can use the first method that we have discussed in the past video. That's method of undetermined coefficient, or we use variation of parameters. So today we want to concentrate on variation of parameters. How do we apply variation of parameters? In this case now, variation of parameters, a particular solution using variation of parameters, assume this value. The particular solution is going to assume this value. This is the value. This is how we are going to write the solution under variation of, when we want to use variation of parameter. Y of p will be of this one. Then how do we get from where y1, y2 up to yn is gotten from the complementary solutions? So these are the solutions that we have in the complementary solutions. But what about v1? Where vi are the unknown functions of s to be determined. So we use this variation of parameter to discover v1, v2 up to vn. Then what can be done? Look at, if we want to apply variation of parameter on the particular solution, we are going to write the equation. We are going to write something of. We are going to rewrite what we are given in form of linear equation, and we are going to solve this simultaneously. That is, we assume this to be v1 prime. That is the derivative of v1 y1 plus derivative of v2 y2, depending on the order of the differential equation. If the order is second order, if let's say we have second order, for instance, then we are going to stop at this. We only consider these two. Then we only consider these two, okay, as the first one. Then the second one is when we find the derivative. That's what we are going to do. That's the only thing that we are going to consider. So in this first one now, we only have y prime here. But the next one, we are going to have y prime, y1 prime, y2 prime. Then at the last one, that's when we have the right hand side here. We are going to put the right hand side here. So I'm going to use example to buttress my points on how to use variation of parameter to find the second solution of non-homogeneous differential equation, which is the particular solution. So I'm going to repeat the same example that we used under the first method, so that we'll be able to compare the two results and see if we can actually apply any of these two methods. So I will start with the first example that we use under method of undetermined coefficients. So let's take this example. Let's say example 1. Solve y prime minus 2y prime minus 2y is equal to 4x squared. If you check my past video, you realize that we have solved this problem using the first method. So we don't want to apply variation of parameter to be able to solve this now and see if you are going to get the same result. Of course, the first thing to do is that we equate the right hand side to be equal to 0. Y prime minus 2y prime minus 2y is equal to 0 in order to find the complementary solution. So that's the first thing to do. So the characteristics equation in this case will be m squared minus 2m minus 2 is equal to 0. That's what you're going to get. If you want to find out, that's what you're going to get. Then what are the values here? What are the values that we're going to have here? What are the values that we're going to have here? So if you want to solve this now, how do we solve this? And what are the values that we're going to get here? So let's go ahead and solve this. We should go ahead and solve this. So if you want to solve this now, what are the values that we're going to get here? So from the characteristics equation, you know, it's in form of quadratic equation. So we just go ahead and solve. We go ahead and solve the characteristics equation. So what do we do there? And how do we apply that? So what do we do? And how do we apply this? Okay, so we go ahead and solve this. This is the question. Let's go ahead and solve. So what are we going to get here? That is what we are about to do now. That is what we are about to do. So the value in between will now be m squared minus 2m plus m minus 2 equal to 0. That's what we are going to get, m squared. So m is common here. We have m minus 2. Then this is minus m here. Here is minus m. So minus 1 is common here. We have m minus 2 equal to 0. It simply means that plus 1. This is plus m. Plus 1 is common here. So m plus 1, m minus 2 equal to 0. So m is equal to m plus 1 equal to m plus 1 equals 0, or m minus 2 equals 0. So m is equal to minus 1 or m is equal to 2. So the complementary solution here will be the complementary solution here is going to give us the complementary c1 exponential minus x plus c2 exponential 2x. This will represent the complementary solution. So once we know the complementary solution, that is when we can go ahead and find the particular solution. But from this complementary solution, if you compare it with what we are given, you realize that this is same thing as yc, same thing as c1 y1 plus c2 y2. What can you deduce from there? You realize that from here now, I'm about to start the particular solution now. From here now, we have gotten the value of, please let's note the value of this complementary solution. Let's note it. Because at the end of the day, we are going to add it with the value of a particular solution to get the general solution to these non-homogeneous differential equations. So from here, if you compare, you realize that this is y1 and this is y, here will be y2. It is from the complementary solution that we are going to get the value of y1 and y2. So we just say yc is equal to c1 exponential minus x plus c2 exponential 2x. Okay, so from here we know that y1 is equal to exponential minus x, y2 is equal to exponential 2x. Then from that question, we know that phi of x, that is the right hand side of that equation, is same thing as 4x squared. So what do we do here? I'm about to apply the method now. What do we do here? What do we do here? Once we have gotten this value, what do we do here? We now write this as we know that from there we know that yp, the particular solution, is same thing as v1 yp. We know that yp is same thing as v1 y1 plus v2 y2, because this is second order. Then this same thing as v1 to be determined. Y1 is what? Exponential minus x plus v2 exponential 2x. This is what we are going to get. This is why this represents our particular solution. So the problem now is that we have to find the value of v1 and v2. How do we find the value of v1 and v2? Let's write this as a system of linear simultaneous equation. That is, what we are going to do is that we say v1 prime y1, okay, plus v2 prime y2 is equal to 0. That will be the first one. Then we now say v1 prime y1 prime, we are going to differentiate this, plus v2 prime y2 prime is equal to the right hand side, 4s squared. This is equation 1, and this is equation 2. So from this now, we are going to solve these two equations simultaneously in order to find the value of V1 and V2. Once we know the value of V1 and V2 and we substitute, that will represent the particular solution. And once we know the particular solution, we just combine it with the complementary solution. And that's going to give us the general solution to this problem. So what do we do here? What do we do here? This same thing as, what we have on board, the same thing as V1 prime. What is Y1? Y1 is the same thing as exponential minus x plus V2 prime. What is Y2? Exponential 2x is equal to 0, equation 1. Then V1 prime, then Y1 prime. Let's differentiate this. If you differentiate this, we know Y1. If you differentiate Y1, that's Y1 prime. That will be minus e minus x. Then plus V2 prime. Let's differentiate this to get Y2 prime. That will be into bracket 2e2x is equal to 4x squared, equation 2. Okay? Then what do we now do? We now solve the two equations simultaneously. We solve the two equations simultaneously in order to get. So what do we do here? How do I, if I say equation 1 plus equation 2, what will happen? This is V1 prime. There's exponential here, minus exponential here. This can cancel out. At the end of the day, this is 2, this is 1. If I add these two together, I'm going to get V2 prime 3 exponential 2x is equal to 4x squared. Okay? That's what we're going to get. Then, if I V2 prime will now be 4 all over 3 x squared exponential minus 2x. That's what this will represent the value of V2 prime. But we are not to find value of V2 prime, but value of V2 and V1. But at least we have got the value of V2 prime. So let's go ahead and find the value of V1 prime. So what do we do here? We substitute this value now. Value of this V2 prime into equation 1. Substitute V2 prime, which is equal to 4 all over 3 x squared exponential minus 2x into equation 1. What is equation 1? We have V1 prime exponential minus x plus V2 prime. V2 prime now, we substitute for this value, which is 4 all over 3 x squared exponential minus 2x multiplied by exponential 2x is equal to 0. That's what we are going to get. So from there, I want us to get the value of V2. From there, this can take care of this. So that at the end of the day, this can take care of this. So that at the end of the day, V1 prime will be equal to minus 4 all over 3 x squared, then exponential x. That's what we are going to get here. So this is value of V1 prime. So we are required to find V1 and V2, not V1 prime and V2. But since we know V1 prime and V2 prime, then the only thing is that we just integrate for us to be able to get this. Then this is what I'm trying to say. If I want to get V1 prime, if I want to get V1, I will integrate this solution. Once I integrate this, I'll get V1. So what do I do here? I'll just say V1, integrate both sides. If I integrate both sides, I will integrate both sides. So if I integrate both sides, I'm going to get V1 to be equal to minus 4 all over 3 integral s squared ex dx. But if you look at this integral now, we have s squared ex dx. So when we have integration of two functions, if you have integration of two functions, we are going to use integration by parts to be able to solve that. Then by applying integration by parts, by formula, is integral v du is equal to uv minus integral u dv. That's what we are going to get. So that is what we are going to get. Let's call this one v, and we call this du. So if v is equal to s squared, if v is equal to s squared, then integral du will be equal to integral ex dx. So what is dv? dv will be equal to 2x. dv is going to give us 2x dx. Then u is going to give us ex. So how do I get this value? So that v1 will be equal to minus 4 over 3 integral, minus 4 over 3 into brackets. I will substitute for the value into brackets. U and v will give us, this will give us s squared ex minus integral 2x ex dx. That's what we are going to get. So this same thing as minus 4 all over 3 into bracket s squared ex minus, I will apply integration by parts on this second one also, because we still have product of x 2x ex minus 2 integral ex dx. That's what I'm going to get. Then finally, v1 will be equal to minus 4 all over 3 into bracket s squared ex minus 2x ex minus, that will give us, when I integrate this, there's central minus here, this will be minus, then here will be plus 2ex. That's what I'm going to get. So that this will be the value of v1. So I've gotten the value of v1. I will write it somewhere. This value of v1, that will be the value of v1. That will be the value of v1. I will come back to v2 here. Let me solve for v2 here. I've got the value of v1. Then I will come back to v2. How do I get the value of v2? I will integrate both sides so that v2, when I integrate this, will be equal to 4 all over 3 integral s squared e minus 2x dx. Of course, this same thing as 4 all over 3 into bracket. I'm going to apply integration by part on this because this is the product of two functions, exponential function and polynomial function. So if I apply integration by part on this, because this is what I want to do now, I will apply integration by part on this. If I apply integration by part on what I have here, at the end of the day, if I apply integration by part on that, I'm going to get minus s squared e minus 2x all over 2 plus integral e minus 2x all over 2 multiplied by 2x dx. This will take care of this. At the end of the day, I'm going to have 4 all over 3 all over minus s squared e minus 2x all over 2, okay, plus x. I'm going to have integral x e minus 2x dx. So this is the product of two functions. I'll still apply integral by part on this. I'm going to have 4 all over 3 into bracket minus x squared e minus 2x all over 2 plus, I will apply integral by part again on this. So if I apply integral by part on this particular value, then if I apply integral by part on that, I am going to get, this is what I'm going to get. At the end of the day, I'm going to get minus x e minus 2x all over 2 minus e minus 2x all over 4. That's what I'm going to get. So this will represent the value of v2. So I've gotten the value of v1. I've gotten the value of v2. Of course, since I've gotten the two values, I can go ahead. By now, I can go ahead and substitute this value of v1. This value of v1. Then this value of v2. Since I've got the value of v2 and v2, I'll just go ahead and substitute the value in the general form that we know. That is, I will go ahead and substitute. I will say yp is equal to yc, and yp is equal to v1 y1 plus v2 y2. That is what we know. So I will go ahead and substitute the value there in order to find a particular solution. So if I do that, what are we going to get? From here now, we know that v1, this value of v1, minus 4 all over 3 into brackets s squared ex minus 2x ex plus 2ex into brackets y1 is e minus e raised to minus s plus v2, this value of v2, 4 all over 3 into brackets v2 is set as 4 over 3 into bracket. I can open up into brackets, or I can open up and say, or let me just write it like that, s squared e minus 2x all over 2 minus x e minus 2x all over 2 minus e minus 2x all over 4 into bracket. What is y2? Y2 is exponential 2x. Okay. If I now solve this now, I will be able to get the value of the particular solution. So if I solve this, I will be able to get the value of the particular solution. So what will happen here? Of course, if I use this to multiply everything here, it's going to cancel out if this you multiply everything here, it's going to cancel out everything here. So that I'll be left with minus 4x squared all over 3 plus 8x all over 3 minus 8 all over 2. Then here plus, what am I going to get here? I have 4 over 3 here into bracket. If this multiply all through, it's going to cancel everything here. So that at the end of the day, I'll be left with minus 4, no, here 1. No, I'll be left with, let me just leave it. I'll be left with minus 4x squared all over 6. Then minus 4x all over 6. Then minus 4 all over 12. That's what I'm going to get. So finally, if I start to collect the like answer, I'll have minus 4 over 3. In this case now, here will be 4 here 1, 4 here is 2. That will be minus 4 over 3 minus 4 all over 6, everything x squared plus 8 all over 3. I'll go for that of x. So plus 8 all over 3. 8 all over 3. There, what are we going to get in that other side? In that other side there, we are going to have the one with 8 all over 3. This is 4. Then 3 times 2. 3 times 2 is 6. Here is 4 all over 6. No, I've taken care of this. I've taken care of this because this times this is 12. So I've taken care of this. This will not be there. So here I will have minus 4 over 6. Then here I'm going to have minus 4 all over 6 x. Then the constant minus 8 all over 2. Here I'm going to have minus 4. Minus 4. Here I'm going to have minus 4. Here is minus 1 over 3. This minus 1 over 3. That's what I'm going to get. So at the end of the day, if I find the LCM here is 6, 2. That's minus 8 minus 4. Everything into bracket x squared plus here the LCM is 6. Okay, 3 here. That's 16 minus 4 into bracket x. Then here I'm going to get minus the LCM here is 6. 2 here, 3 times minus 18. Minus 18 minus 3 here. 3 here. Minus 8 all over. No, this is 8 all over 3. Yes, over 3. So here I'm going to get 3. 3 and 3. That's minus 8. I'm going to get minus 8 minus 9. So that's what I'm going to get here. This is plus. And here will be minus. Minus 8 minus 1. That's minus 9. At the end of the day, so here will be plus. At the end of the day, the final answer, yp, will now be minus 8 minus 4. That is minus 12 divided by 2. That will be minus 2x squared. Plus 8 by 16 minus 6 is 12. Plus 2x. Then minus, that will be minus 3. This is the value of our yp. This will be the value of our yp. So finally, if you compare the two results, when we use method of variation of parameter and method of undetermined coefficient, you realize that the value that we got, the value that we arrive at is the same. Finally, we now say that the final solution to this problem now, the final solution, which is y, will be yc plus yp. So yc is same thing as c1 exponential minus x plus c2 exponential 2x, then plus yp now will now be minus 2x squared plus 2x minus 3. This will be the final solution, the general solution to that example 1. So if you compare this solution and the solution that we arrive at when we use method of undetermined coefficients, you realize that we get the same solution. But just that this method of variation of parameter is somehow lengthy. The process involved is longer than method of undetermined coefficients, but it has an advantage over method of undetermined coefficients. As we proceed in this course, we are going to see the advantage. Thank you.